Welcome back to the channel. This is Roberto with Full Curl Precision again. Oh, what a crazy day. It's been a long day. Got a lot of stuff done. So tonight, we're talking about several different things. But just as a real quick thing, let me turn this camera around. I did a post on this, but this is the ammo that I'm going to be using to fire form into my 27 IBEX. So I just put these together. These are some Berger target bullets. I'm not going to use them for hunting at all, so it doesn't. I have to basically have sacrificial bullets, basically, for lack of a better phrase. So I'm going to sacrifice all of these to make the new brass. So yeah, this is gonna mold the new casing. So yeah, 100 rounds. So I have new brass. Once I'm able to go get the rifle, I'm still waiting on the gunsmith to get back to me. Again, he's always busy. He's a one-man show, so I'm not really in a hurry, and I'm not gonna press him because you know what? He's busy, and I understand it. So this is something. Let me zoom out. You know, in one of the previous videos, I was talking about learning to invent, about why the shape matters, things like that. Talking about surface area inside of a barrel. The reason why less grooves oftentimes leads to higher velocities is because you have less resistance. And so it kind of got my brain going, and I'm going to work on a project. And this is just ideas. This is anywhere far from what I'm going to be doing. But just because I have a 27 caliber and I like to work with them, it's just a predecessor to things to come. So what I'm really looking to do is develop a new pattern inside of a barrel, and I'm going to be doing that. I'm not going to disclose the exact one because I'm kind of settling on one. But what I am going to be doing is giving you an idea. What I start with some ideas and I kind of work through them. So while this isn't to scale, don't worry about any of that. This is not to scale. You know, I'll draw, like you can see there's like a semicircle here, portion kind of representing the bore. Here's your bore diameter. And so when you do the difference of between what is the actual bore diameter and then the bullet, so you got 0.277 is your bore, and then the top of the groove, also known as a lands area, that is 0.270, hence 270 Winchester. That's really what it's based upon, is the top of the lands. And so you get the difference of 7 thousandths. Now, the way it works is because that's going to sit inside here. So you have your bore, which is right here, and then you have a smaller circle that sits inside. That's your lands area. That's the actual squeeze. That's the squeezed area, right? The difference is 7 thousandths. But whenever you're designing at one side, you never put the whole difference of 7 thousandths, and it varies per cartridge, or rather per caliber, but you don't put that the whole thing, because half that distance goes on this side of the bore. So let's say this right here, this groove is here, right on the bottom of the bore. You have to have that you only get half of that 0.007. You have to divide it by 2. So you bring up the total height of something like this to a height of 0.0035. And then, you know, this is just, I'm going back and forth between numbers, toying with them. And so my buddy who helps me do the 3D printing on these, he has a CAD program. So I work on the ideas here and then give him the ideas, and we put them to a CAD program and we get that all going. And so we're going to be working on a new rifling design with the hopes to not only have something that is just as good, if not better, at its accuracy than your standard 6s or your 5s, but to have something that it shoots considerably faster. Because, you know, with the trend of going to shorter and shorter barrels, Every little bit helps. And so if you can somehow, by reducing your resistance inside your bore, to have it shoot really, have a 20-inch barrel shoot really close to the velocities that you can get out of, like I say, a 24, that's a big accomplishment. And so while I still would love to keep a 22, 24, 26-inch barrels, I love them because you maximize your burns and you get better velocities. If there's ways to achieve better velocity and tighter accuracy while using the same case volumes and everything you already have, that's going to be phenomenal. But here's the other side too. And we're going to use this as a simple example. Let's say you have something like a 270 WSM, okay? And with a 130 grain bullet, you can get 3,300 feet per second out of a 24-inch barrel. All right? Well, if out of a standard 270, you're getting about 3,150 to 3,200 feet per second out of a 24-inch barrel. If you can change up your grooves inside to get a standard 270, which uses less powder than a 270 WSM, and achieve the 3,300 to maybe even 3,350, then why wouldn't you? And the nice part about it is then you start chambering those more affordable cartridges that use less powder, and you're achieving the same velocity. So it's not just a matter of case design difference, it's also your rifling styles. Actually, let me pull out my other drawings. Or should I say illustrations? So these are just illustrations. So like this one showing, like, let's say you went with a 3-angle. So you got like a 3-angle. So you have, think of it like a Mercedes-Benz symbol. So you got, here you go, and then you come 120 degrees down, you hit that one, and then you come 120 degrees down there because you get 360 degrees around a circle. But if you notice, these are just ideas. Even though you have a semicircle as a cross-sectional cut, if you shave off a little bit over here and like a little bit over there, that's a shorter distance, right? It's a longer distance to go fully around the semicircle than it is to simply cut it off. And so even though you have the same protrusion height into the bullet and the same width on your groove, by shaving off even just a little bit, you can actually reduce your surface area. And then, so you take something like that where you're reducing your surface areas, and then you do things like this. So here it is. This is a standard 6. This is common. Now, obviously, this is not the scale. It's just to illustrate the positions of where your grooves are going to be. And typically, they're a more square cut type groove. There's nothing wrong with that. They're just not that efficient. They can be very accurate, but in terms of like getting the best velocities, you don't get that. By simply removing a groove, you have less resistance. So if you can remove a groove and then also change your shape, you can achieve better velocities. Because again, one less groove to cut into the bullet means less resistance. Smaller surface areas, less resistance. And then I illustrated it like this because now you can see this one. Here we go. So going back into things like the shapes. So here's a more, now obviously this is not the scale, it's just to show an idea. When we say square cut, obviously it's not exactly like this, but it's similar to that. So you have square, semicircle, and the semicircle considerably less surface area than that, right? And then you take that same semicircle over here and you keep something like that, like a slightly rounded top, and then you cut off there, you end up shaving off even more. So you combine with trying to minimize surface area contact in your rifling, but still cuts good enough into your into your copper jacket that it grips it really well, and then you also reduce down your numbers, you can actually achieve some really good velocities while still maintaining your accuracy. And that's kind of the entire point. It's not to make things obsolete as it is to keep improving. It's not because, oh, I think I'm better than somebody else. No, it's just, it comes down to, I'm a hunter, I'm a shooter, and I like to also invent, design, engineer, and come up with new ideas. And not just new ideas, ones that are practical. That's the one thing I want to say. If you're someone that's watching this for the first time, or even if you're not someone who's new to the gun industry or any sort of industry of mechanicking of any kind, the biggest thing to consider when coming up with a new idea is its value. People will consistently value things that are useful over things that are not. Now, what do I mean? Well, it's simple. There used to be an old saying that used to say, oh, form over function. And I used to hear it all the time when I was doing architectural drafting classes. And what it means is that people focus on how it looks more than how it functions. Yeah, only if they're stupid. And here's the thing. From so far in talking with the most folks that have been subscribed to my channel, listen to what I'm talking about, you aren't that. You guys aren't dumb. You guys, like myself, y'all, prefer to have something that does its job, performs as advertised. You're more concerned about function than you are about form. Form is nice, but it'll never be as good as the function. Something doesn't have to look very good in order to work amazing. And I think you're like me in that regard. So you are the people that I'm trying. So to those watching this, liking, commenting, you're the ones I'm appealing to. I think you guys are ready for something that's going to rock the industry. Now, is this it? No, that is not it. But this is an idea. It's a starting point. And these are just starting points. These are concepts. So if you're thinking that this is going to be, oh, he's going to come up with this and this and this. No. I have something else in the works that's going to be even better than this if it works out the way my brain is thinking. And again, like I talked about before, when it comes to things like shapes, is you want to follow what the laws of nature want to give you. So there's physical reality, and physical reality says that it is easier for materials to mold around a rounded object than it is to mold around a square cut object. Like when was the last time you saw a perfect 90-degree sharp cut corner in a river? You don't see it. Trees aren't square. They're round. Rocks, river rocks, are round, right? Most things have rounded off edgings. Now, are there some structure that allows for sharp cut and trapezoidal and other geometrical shapes? Of course there are. But typically, most lean towards something more rounded. And the same thing when it comes to metal. It prefers to be, it's easier to mold around something that's round. So why fight the natural process? Create with it. And that's going to kind of be my driving point. So not only am I trying to engineer, or not trying to, but have engineered this new cartridge, and it's coming to fruition. Again, I have to wait on the gunsmith. That's its own thing. So I know those who are following are like, man, can't wait to see this new thing. Guess what? I'm with you there because I'm excited too. And, I know it works because the gunsmith shot it and he sent me the picture of the new casing. It works. My idea works. And that makes me happier than you can imagine. So please be patient. Please keep following. I promise it's coming. I'm just biding my time because guess what? I can't rush the process. If I do, it's going to come out, worse. I don't want to have that happen. I want the thing done right. Not to mention, I told him I need it done perfect the first time. I'd rather wait a little bit and have him do it just to perfection than to rush the job because I'm in an all-fire hurry and then end up not being as good as I was hoping for. In which case, I wouldn't blame him for that. That'd be my mistake because, that'd be my fault. So my thing is do it right the first time and don't have to go back and do warranty work. That's my thing. I hate having to go back and re-engineer and re-engineer and re-engineer. I'd rather do it on paper the first time than having to go back and fix things. So that's my goal. That's my plan. But yeah, so when it comes to this, it's easy to change things on paper. It's easy to change things in a computer program. But once the physical reality takes place, you can't undo it. So yeah, this is what I'm also endeavoring. It's not just a matter of collecting, reloading data to eventually put on the website we're working on. That's going to be cool unto itself because I want to be able to put data from experienced reloaders, not guys who are paid to sell numbers. That's what I'm looking for. Real world numbers. Like what your exact primer, your exact brass, your exact powder charge, your elevation, the type of chronograph you're using, your barrel length, the number of grooves you have, the twist rate, anything that affects those velocities and those performances. That's what I'm looking for. Real world data. Do you need to have the fanciest or expect you to go out and spend money on anything else? No. But just share what you have. That actually means a lot. I'm not looking for anything in terms of exceeding SAMI spec type pressures or CIP pressures. Because at the end of the day, as one of my followers said, that I guess Alpha Brass, they're really good, and you can shoot exceedingly high pressures, and their brass holds up really well because they did a really good job with it. But at the same time, I don't want somebody mistakenly taking that kind of data and not reading that portion that says using Alpha Brass only, and then apply it to something like a standard, whatever. Let's say it's Hornady brass, or Sig Sauer brass, or Federal brass, or whoever. I don't want them putting some high over pressure powder charge and blowing up their gun. So I want everything to stay within standardizations. So if somebody, maybe charges it a little too hot, the worst they have is a primer blowout, and it doesn't damage them or their rifles. So that's important to me. Same thing with you when it comes to your bullet selection. Staying within reasonable bullet selection is a great thing. That'll be very helpful. Yeah, this is going to be a lot of fun. I think we're on to something. If you have ideas, or even if you're working on something yourself and you want some help with it, as far as engineering or coming up with ideas for it. Let's say it's a new cartridge, or maybe it's a new barrel, or maybe it's a new action. While I don't have a ton of experience with engineering actions, you know what? I can still do my homework. There's ways to look up things, and that I'm willing to do. There's always, and if I don't know something, I'm not going to pretend. I'll either look it up and see what I can find, or I'm going to direct you to somebody who actually is much more experienced than myself. So that's all I have for tonight. Please like, subscribe, share, comment, hit that notification bell. If you're wanting to get in on things like this or whatever the case is, we're always looking for those who want to achieve the next level. So if you're wanting to try something different, then I'm always willing to work with somebody. So again, that's all I have for tonight, and we'll talk to you again.